Hydropower, Making a Splash by Amy S. Hansen. Energy from moving water. A river rushes under a bridge. Ocean waves swell. The outgoing tide pulls water back from the shore. All this moving water has energy. When we capture and use this energy, we call it hydropower. In the past, people used hydropower to turn water wheels. Now we use it to turn turbines and make electricity. To make electricity, the water has to be moving fast. Sometimes we use water flowing over a waterfall. Other times we build a dam so we can control the water's flow. Hydropower is a clean, renewable energy source. We do not use up the water. We simply borrow its energy. If you look at big waterfalls, such as these in South America, you can easily see the power of moving water. Why water moves. Water is always moving. Every molecule of water on Earth is part of the water cycle. This is the pattern of changes that water goes through as it moves across Earth's surface through the atmosphere. You can see liquid water in rivers, oceans, and puddles. The sun warms this water. This makes some water molecules evaporate or turn into a gas called water vapor. As water vapor rises, it cools and condenses into clouds. When clouds get heavy, rain or snow falls. Rain and melted snow flow into streams and rivers. The cycle continues, powering turbines around the world. You can see the rain pouring out of this cloud. The inset shows the drawing. This drawing shows how water moves through the water cycle. Water power through history. The water cycle has been around for billions of years. Several thousand years ago, people started using water wheels to capture moving water's energy. Ancient people used water wheels to do many useful things, such as grinding grain for flour, cutting wood, and operating bellows for making iron. In about 65 BC, a Greek poet even wrote a poem honoring water wheels. People in ancient India, China, and Syria used water wheels too. Hydropower was important in American history. It powered mills to grind grain and weave cloth. In 1880, people made electricity using a water turbine for the first time in Grand Rapids, Michigan. Mabry Mill in Meadows of Dan, Virginia, was built in 1910. Today it is still used as a grist mill, or a mill that grinds grain into flour. Electricity from water. Most hydroelectric plants are along big rivers. For example, the Niagara River in Ontario, Canada, and New York supplies lots of electricity. Every second, more than 530,000 gallons, 2 million, 2 million liters of water shoot over Niagara Falls, dropping 167 feet or 51 meters. Upstream and downstream, hydroelectric plants produce electricity. When rivers do not have waterfalls, engineers may build dams. Dams hold back a river's water and form bodies of water called reservoirs or lakes. Dam operators let water out through pipes in the dam walls. The falling water spins turbines. These turbines turn generators that make electricity. Large hydroelectric plants, such as the one seen here, often have more than one generator to make electricity. The mighty Hoover Dam. The Hoover Dam on the Colorado River between Colorado and Nevada has a huge hydroelectric plant. The big dam is 726 feet or 221 meters tall. When the dam was first built, the Colorado River filled up the reservoir called Lake Mead. Lake Mead is 110 miles or 177 kilometers long. To get electricity, engineers let water from Lake Mead flow into pipes. The water falls, spinning turbines that make electricity. The water then continues down the Colorado River. The Hoover Dam produces enough electricity to power a city of 750,000 people. The electricity goes to Arizona, California, and Nevada. A total of 21,000 people worked on building the Hoover Dam.